Bismillah ar-Rahman ar-Rahim. Let's look at this example. It's an old final exam problem. We have a static mixer. The flow is given 10 meter cubic per minute. Diameter of that mixer is 0.4 meter. The manufacturer you are working with report that the length of every element over the diameter of the static mixer is 1.5. The friction factor is 0.75 for every single element. How many elements are needed when time is greater than or equal to 2 seconds? And the G value is completely achieved. First, we need to find out the volume. The volume of every element. Okay, so now the volume, it's pi over 4 the diameter of the static mixer times the length of every element. Now, this would give you pi over 4. Diameter is given 0.4 meter square. The length of every element, as we need to find this length of the element, is equal 1.5 d. 1.5, the diameter is 0.4 meter, and this would give you length of the element 0.6 meter. So this is going to be 0.6 meter, and that is the length of every element. Now you do the pi over 4.4 square times 0.6. This would give you the volume of every element. The volume of the per element is 0.0754 meter cube. What is the total volume required for the whole static mixer? So this is, I'm going to call it element. So the volume required is equal the flow rate times the time. Again, the time here is 2 seconds, equal to 2 seconds, or is equal or higher than 2 seconds. We're going to take the equal one, 2 seconds, and that's Q is 10 meter cubic per minute. The time is 2 seconds. We should change the second to minute. 1 minute, 60 seconds. Minute with minute, you'll end up with meter cube. This is the total volume. This would give you 0.33 meter cube. And now we want to find out, since we have the total volume and we have the volume of every element, now we need to find out number of elements. How many elements? Here there's one element, second element, third element. So we need to find out number of elements. Number of elements is equal, what is the total volume, 0.333 meter cube, over the volume of every element, 0.0754 meter cube per element. And this would give you number of elements. If you divide this by this, you will get 4.4 elements. Actually, it's impossible. It's impossible to have 4.4 elements. So you're going to use 5 elements. That's the next. Of course, you need one element for the water to go up and then down. You're not going to be having 0.4 element. Something has to go up and down. If you look at it, to have a complete element, the water will come in, will go up and down. That is a complete element. You're not going to have 4.4. So the best is to have 5 elements. So this is the first approach. Now, let's find out the length. The total length of the static mixer. So the length is equal. We have 5 elements. And the length of each element, we have it here, 0.6. That's now the total elements. Total length, I mean, total length of all elements, of all the static mixer, of all the elements altogether. Now, remember from the notes, we should find the head loss Remember the head loss total for the whole elements, friction factor L, length, velocity square over 2g diameter. We have F, we have L, we don't have the velocity. Let's find out the velocity. Remember from continuity, Q is equal area times velocity. So velocity is equal Q over area. Q, we have it, 10 meter cubic per minute. The area is, of course, pi over 4d squared, and we have it. The area is, okay, pi over 4 d squared, and that is, if you divide this by this, you will end up with a velocity of equal to, and plus we're gonna make everything, since gravity is per second, we need to change minutes to seconds. Minute is down, so minute up. So you'll end up with per seconds, and of course meter cubic per meter squared, that's gonna give you the velocity 1.33 meter per second. So now we're gonna go and put it into this equation. What was the friction factor? 0.75. What is the total length? 3 meters. What is the velocity? We just found it, 1.33 meter per second, and that is square. What is 2? What is 9.81? The gravity constant. What is the diameter? The diameter is 0.4 meter. So once you plug in the equation, you will get the head loss in meters. So this would give you 0.507 meter. This is the head loss of the static mixer. Now, let's find out, we need that head loss to find out the power. So the power from the notes for the static mixer is rho g QH. The density for the temperature given, the temperature is not given here, so I'm going to assume normal temperature. So 1000, that's the density, normal density, kilogram per meter cube, times 9.81 gravity constant, times Q 10 meter cubic per minute, times the head loss, 0.507 meter. The power will be in watt. So first we have now, since the power gonna be kilogram meter square per second cube, we need to convert this minute to second, and 1 minute is 60 seconds. We need to convert that because we have everything in the second. That would give you 829. Remember the watt, kilogram meter square per second cube, which is almost 829 watt. That's the power needed, or the power that's going to be used to mix all these chemical. And then let's see how much this is equivalent to how much G. Remember the equation of G? Mixing intensity, square root power over mu, and then the volume. The power is 829 watt. Mu, the viscosity for that normal temperature is 10 to the minus 3. You have to find the mu based on the temperature given, times the volume pi over 4. Diameter is 0.4 square, and times the length, the total length, of course, and that will give you 3. And thus, if you do the actual G, even though there is no fans, there is no mixers that will do the mixing intensity, but the elements will do the something equivalent to this 1483 G. This is how we design a static mixer. Hopefully this will clarify